The optimum selections for A and B will be the same as the effect plot. Okay, so even though the prediction using identity model is no good, however, the best combination still okay. Your selection for the best combination still working. You don't need to change the selection. This is synergistic, right? Just like this one. This is the effect plot for AB. And the selection, the best selection will be A2 and B2, right? A2 and B2. What is the selection from the interaction plot? You just need to see which combination will give you the largest SN. So you can see this combination will give you the largest, right? And this combination is B2 and A2, right? This combination, there are 4 combinations for AB, for 2 label factors. And here, the best combination from the interaction table, interaction plot, will be A2, B2, which are the same as the effect plot. Well, I believe you will know what I'm going to say next. What happens if they are anti-synergistic? First, the slope will change sign. If 2 factors AB has interactions, and which is anti-synergistic, then the slope will change direction. B1, the slope is positive, but B2, the slope becomes negative. The slope change direction, which means that the selection of the better level for A will change. So the optimal setting of one factor will depend on another. Which level is better, A1 or A2? The answer will depend on the selection of factor B. So if anti-synergistic presents, anti-synergistic interaction present, then the selection of the optimum combination from the effect plot will be different from the selection, or I should say might be different from the selection from the interaction plot. Let's look at this is the effect plot. And the best combination will be A1, B1. However, since AB has anti-synergistic interactions, from the interaction plot, which combination will give us the largest SN? Here. Okay, 4 combination, and this combination will give us the higher SN, right? This is SN. So this combination will give us the highest SN, which is B1 and A2, different from A1, B2, B1. We conclude from the effect plot. So, which means that if I determine from the effect product will be incorrect, then the optimal combination should be determined from the interaction plot if there is an anti-synergistic. Just by look at more exercise and by compare with the initial effect plot and the interaction plot for AB. And we should double check the type of interaction by using different base. The interaction of AB, the interaction plot can be drawn by using A as the horizontal axis or B as the horizontal axis. If there are no interaction, no matter your selection of the horizontal axis, those interaction plots will look parallel. And also, it will parallel to the original effect plot. The dashed line is the original effect plot for each factor, A1, A2. And this is the effect plot for B1, B2. And the interaction plot will be parallel to the effect plot. And the optimum combination will be the same, no matter you look at the effect plot or if you look at the interaction plot. But if there is something like that, okay, when you draw A as the base and you have a plot like that, and is it anti-synergistic or synergistic? anti-synergistic or synergistic. From the first look, it looks like a synergistics, right? Because the slope are all the same. They are all positive. But this is only use A as the base, which means that the best selection of A will always be A2, no matter from the effect plot or no matter the selection of B. But if you draw the curve using another one as a base, using B as a base, then you might conclude you have a different answer. If you are using B as the base for the same interaction, you will find out these two interaction has what? Is anti-synergistic. Since the slope direction change, it was positive when A2. The green, when A is changed to A1, the slope become negative, which means that AB will have anti-synergistic. When they have anti-synergistic, the best combination should be selected from the interaction plot. If you are only look at the effect plot, you can look at this dashed line is the effect plot for A. This dashed line is the effect plot for B. And from the effect plot, your selection will be A2 and B1. This is from effect plot. But if you are look at interaction plot, what will be the best combination? You can look at here. The best combination, there are 4 combinations. The best combination will be this one. Since this combination will give us 50, SN ratio to be 50. And the combination will be B2 and A2. So if you look at the interaction plot, the best combination will become this one from interaction plot. So you can see the selection will be different if there is a anti-synergistic exist. So let's go back to the Excel file. This is the interaction for AC. And here I use C as the base. You can draw the same curve by changing the base to another factors by click here, right? Click here and right click. And what else? 选取资料, selection of data. Okay? And you'll come up this selection. Here, you can see the horizontal. This is the 图例. Horizontal over here. The horizontal is C1, C2. And the 图例, which means that the color is determined by factor A. You can switch it by click here. See, if you click it, they can switch the horizontal axis to A. And you understand my questions. If you, some of you might have this curve, and they will feel confused because they are synergistics. Why? Because the slope are the same. But the trick is if there's an intersection, okay? If there's an intersection, which the plot will mostly anti-synergistic, only if you switch the base. So if you find out these two lines are intersect to each other, even though they are the same slope, they are still anti-synergistic because you just need to switch the base. Okay, let me try that again. Right click, 选取资料, select of data, and it will show you the selection of a horizontal axis, which is C1 for now. And you click here, change column and row, right? You'll change to A. Click again, you'll change back to C. So it is better to double check by selection different base and to make sure this is synergistics or anti-synergistic interactions. Any questions? Even though it looks like synergistic, However, if you change the base, you will find out they are actually anti-synergistics. If they are anti-synergistics, it will cause problem. It will introduce some problem for your selection of optimum combination, because in your selection of optimum combination, if there is an anti-synergistic, the selection from the effect plot will be different from the selection from the interaction plot. And you should use interaction plot as a correct selection. Let's go back to the verification table. Remember, in the last chapters, we have these 4 cases, right? This is the predicted result, and there are 4 possible cases. And the first cases is strong confirmation, remember? And the second one is weak confirmation. But when you look at again, they are all very similar. So case 1, case 2 are okay. The selection of the optimum combination will be good, which might be the best in the full factorial for case 1 and case 2. They are all confirmation. But first one is strong confirmation. This one is weak confirmation, because the gain are the same, but the prediction result for robust and initial will have some static difference for case 2, but still okay. However, for case 3, remember, we say this is bad confirmation. Why? Since the gain is outside the 50% tolerance range. Prediction is about 20. So the upper bound will be 30, lower bound will be 10. And the verification result, if the gain is more than 30, we say this is bad confirmation. Why? Because of interaction. However, in this case, the interaction is possibly synergistic. Therefore, the selection of the optimum is still okay. If it is case 3, remember, I said that if this is case 3, the optimum selection is still okay. Why? Because it is possibly synergistic. It is possible synergistic interactions. So the selection of the optimum, good. But if it is case 4, it's on the lower bound, the prediction is much worse than the actual result. The verification result is much worse than the prediction. It's smaller than 50%. Then it is possibly anti-synergistic. So if this is case 4, this will be possibly anti-synergistic interaction. Then your optimum combination using effect plot will be incorrect. What I mean incorrect is you cannot guarantee the combination is the best in the full factorial. Okay? So if it is case 4, be careful. Your combination from the effect plot may not be the best in the full factorial. Okay. So here, how do you know if they are synergistic or anti-synergistic? Or how do you know which 2 factors will have the interactions? Even though you know there might be some interaction, because the comparison from the verification result is case 3 or case 4. But you need to draw the interaction plot in order to find out which 2 factors will have the interactions. Okay, so we need to do interaction analysis for case 3 and case 4. And will be able to get the interaction plot? Not really. It doesn't mean that you just do the same analysis just similarly to the one I show you and you can get interaction plot. No, there's some premises. If you want to draw the interaction plot, you have to make sure the interaction effect can be estimated using your current design of experiment. You have to make sure your interaction can be analyzed using the current design of experiment. What does that mean? What do I mean by current analysis? Let's look at our dating model again. In this case, the dating model will have A, B, C, 3 factors. And this is the dating model. So from here, you can see mu is the total average, ABC will be the main effect, and epsilon will be the possible error. Right? So from here, if your prediction is different from the actual result from the verification table, you'll know that there might be some possible interactions. So which means that your model should be modified. Okay, your model should be modified. We didn't introduce this model here, or Taguchi didn't want to consider this model here. But in the actual design of experiment in statistics, the model include interaction will look like that, which means that the factorial model, the model will, we call it general linear model. Okay, this is called general linear model. It is not linear adaptive model. For Taguchi's linear adaptive model, they only consider main effects. However, if it is a general linear model, 一般的线性模式的话, this model can possibly include the interaction effect like that. This will make it a little bit more complicated, and we are not going to the details. But if in the GLM, general linear model, these 3 is called two-way interaction effects. When you want to analyze the interaction, you have to make sure the interaction can be estimated. What do I mean can be estimated? And this conclusion will depend on your design of experiment. This will come to the confounding of effect. Because we are using experimental design of fractional factorial, the estimation will based on some assumption, which means that some of the effects will be confused, will be mixed together. And this is called confounding. So right here, the factorial, fractional factorial. Here, Taguchi's orthogonal array is a type of fractional factorial. And the fractional factorial experiment will cause the confounding of the main effects and the interaction effects. Confounding means 交弱. The main effect will confound with interaction effects. I'm going to explain what does that mean. Which means that we are using the effect plot to find out the effect, the main effects of each factors. However, if there are interactions, then the main effects estimated from the effect plot will be inaccurate because the result will be mixed with the interactions. And we cannot differentiate the difference of the output is caused by the different selection of factor or by the inference of interactions. Okay, so Taguchi has some assumptions. If you are using orthogonal array, main effect and interaction will be mixed together. What do I mean by mixed together? I will prove that to you. But if the interaction is small or negligible, then the method still work. We still can, even though I mixed together, but we can still say that the effect of a certain factor is correct. can be estimated using the analysis of mean. Okay, so how will that happen for the confounding? The confounding will depend on your arrangement of experiment. So right now we are talking about the arrangement for the factor to the orthogonal array. Remember, we can have many different assignments, right? For factor ABC, we can put it to column 1, 2, 3, or 1, 3, 5, or 1, 4, 5, right? As you can see, different assignments will have different result. What will be the different result? The confounding structure will be different. And when we do the assignment, we have to make sure that our analysis will give us the accurate result, which means that our many facts cannot be confounded with the interaction, cannot be confounded with the important interactions. Otherwise, our estimation of the main effect will be incorrect. Let's look at the interaction. So how do I estimate the strength of the interaction? Let's look at this example AB in L8 orthogonal array. We just draw a similar curve like that. As I mentioned before, the difference between A1 and A2, if B is set at B1, the difference will be D1. If factor B selected at B2, the difference will be D2. So whether A and B has interactions can be determined by the difference between D1 and D2. Why? As I mentioned before, if D1 and D2 are the same, these two lines will be parallel. If these two lines are parallel, then there will be no interactions, right? Okay, so if D1 equal to D2, no interaction. But if D1, D2 are different, there will be interactions. If the difference is very big and make it change the sign, you will be anti-synergistic. Okay, let's look at these two. What will be the difference between D1, D2, and D1? Let's look at the picture here. What is the difference for D1? Which is the difference between A2, B1 and A1, B1 is D1, right? So what is the difference for D2? The average of A2, B2 and the average of A1, B2. So we can substitute the result over here. D2 is A2, B2 minus A1, B2. D1 is 2, 1 minus 1, 1. Any questions? This is D2. This is D1. And we can rearrange the combination. And let's look at the data over here. This is the corresponding L8. And then we can substitute 2, 2, 1, 2. 2, 2, 1, 1, and 2, 1, 2, 1, 2, right? Depends on what is A2, B2. A2, B2 over here, which is experiment number 7 and number 8. So how do we get the average of A2, B2, which is the average of the output 7 and output 8? So we can substitute the result. Here, 2, 2 will be the average of Y7 and Y8. Same thing, 1, 1 will be the average of Y1 and Y2, because 1, 1, you can look here. A1, B1 are experiment number 1 and number 2. Since experiment number 1 and number 2, the factor A is level 1, factor B is also level 1. So we can get the average of A1, B1. So you can get the result from the data. If you are arrange your A and B in column 1 and 2. Be careful. This will depend on your arrangement of A and B. If you A in column 1, B in column 2, then A2, B2 will be the average of 7, 8. But if you assign A, B to different column, then A2, B2 will be different. You know, right now, A in column 1, B in column 2. If you select A in column 1, B in column 3, then 2, 2 will be this 2, right? If you put B in column 3, then 2, 2 is design number 5 and 6 instead of design number 7 and 8. So the result, the estimation result will depends on your assignment of the factor to the column. And in this case, we are assigned A in column 1, B in column 2. And the interactions, the strength of the interaction can be estimated from the previous analysis. This is the strength of the interaction. But if you assign factor C to column 3, all right, if you assign C to column 3, you can use column 3 to estimate the effect of factor C, right? How do you know the effect of factor C? Which means that we can find out what is the difference between C1 and C2. If you put C over here. So C1 will be the average if C is level 1, and C2 will be average if C is level 2. So here you can look at the result. You will know experiment 1278, C is in 1278, C is in level 1, right? And 3456, C is in level 2. So the difference for the effect C can be estimated from this equation. But you can find out these two equations are dependent to each other. What does it mean? Since they are all the similar format, 1278 plus together minus 3456 plus together. Same thing, right? The only difference is a constant, which means that if you get a larger value for C1 and C2, you will also get a larger value for the interaction A and B. Is that right? Since they are using the similar estimation, which means that when you draw the effect plot and you find out C1, C2 has a big difference, but you don't know the difference is due to factor C or the difference is due to the interaction A, B. Therefore, in this kind of arrangement, we say the factor C will confound with interaction A, B. This kind of arrangement, this kind of design of experiment, A in column 1, B in column 2, C in column 3, will make effect C confound with interaction A, B. How do we do? Well, in this case, we can make an alternative arrangement. You just need to move C to another column, such as column 4. Right now, from the analysis, you will know that the interaction of AB will confound with anything you put in column 3, right? If you put in column 3 like C, these two will confound with each other. So the best case is you just to make the third column empty column, which means that you reserve that for the estimation of interaction AB. And you put the rest of the factors to some other columns, such as column 4. Then if you make this kind of arrangement, C and the interaction AB will not confound with each other. Which means that if you don't put any factors in the column 3, then the interaction AB will become estimable. 这个情况就是把这一行空开来的话，那么这个交互作用在这个情况下就变得可以被估计的，因为 它不会跟其他的主效应交落在一起。So this is what I mean in the previous sections. If you want to analyze the interaction, you have to make sure your interaction is estimable, which means that the interaction cannot be confounded with some other main effects or some other interactions. Any questions? All right. So what do we do if we have some interaction need to be considered in our model? First, we need to find out the confounding structure for our arrangement. How do we get the confounding structures? It's not easy to do this analysis one by one. Fortunately, Taguchi gives us the interaction table. So whenever we arrange the factor to each columns, we can find out what will be the columns the interaction will present. So here, once we want to have a good experiments, we need to make sure our factors, main effects, and those important interactions. For those, no interaction will be fine. If you want to analyze certain important interactions, then this interaction cannot be confounded with the main effect, just like the previous example, which means that some columns has to be reserved for the interactions in order to estimate both the main effects and the interaction effects. Because there has to be some empty columns reserved for the interactions, the orthogonal array has to be large enough. You cannot use all the columns, just like L8 has 7 columns. You cannot assign 7 factors to L8. If you want to analyze the interaction effects. Since if you want to analyze one interaction effects, you should empty one columns reserved for that. Which columns? Taguchi will give you the table for that, which is the interaction table. Interaction table is a combination of tables, might have different format. One of the popular format will look like this one. This is the L8 orthogonal array. L8 orthogonal array will have 7 columns. 7 columns. They have 8 experiments, and they are all 2 labeled. The interaction table will look like that. Column 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. This is from 1 to 6. This is from 1 to 7. Since you don't need to consider the interaction between yourself, okay? You just want to consider the interaction between 2 factors which are assigned to different columns. So there will be no value in the diagonal. 1, 1, no. 2, 2, no. Okay. But if you assign 1 factor to column 1, 1 factor to column 2, then the interaction we present in column 3, just like our previous example. If I assign A to column 1, B to column 2, then the interaction AB. Where's the interaction AB? The interaction AB, A in column 1, B in column 2, the interaction will happen in column 3. Right? We don't need to do the analysis just like what I did before. Taguchi has come up the table for you. So you can just look at the table and you can find out what will be the interaction confound with the column. Which columns will the interaction confound? Any questions? So here you will know A in column 1, B in column 2, then the interaction of column 1 and 2 will happen in column 3 from the table. So here, 1, 2 will happen here. And here, 1, 2 is factor A and B. So the interaction AB will confound with column 3. Then we can find out the confounding structure for any assignment of the factor. For instance, this is the L8. And if you want to analyze three factor A, B, C, and you arrange A, B, C in column 1, 2, and 4, what will be the confounding structure? What is a confounding structure? Which means that you need to find out where is the main defects. By if you arrange main defects over here, what will be the interaction for these main defects? And from the combination, you know, if you have three factors, then the combination will have 3 multiplied by 2, which means 6 combination, right? But since the interaction A, B will be the same as B, A, which means that there is no difference for order. So we need to divide it by 2, 1. Remember the high school, you have did the combination C, 3, pick 2. Combination of 2 from 3, which is the equation like that. So you will have 3 combination. You have 3 combination. We can try it out. AB, AC, and BC, right? 3 combination. 有问题？好，以前应该学过的排列组合。Okay, C 3 by 2. If you want the equation that the equation will look like that, 3 combination m by n will be m multiplied by n minus 1 multiplied by blah blah blah, and here m minus 1, m minus 2, etc. Remember, this is the equation for combination. Okay, and you will go to m minus n. So if it is 3, 2, it will be 3, 2, 2, 1, right? Just like this example. So here we have 3 combination, 3 2 factors interactions. So you need to find out where are they. If you arrange column 1 to be A, column 2 to be B, column 4 to be C, what will be all the interactions? Easy. Let's try from AB, which is column 1 and 2. So look at that. You can put it down here. What is 1, 2? What is the interaction AB? Look at that. 1, 2, 1, 2. So the interaction will be column 3. So you can find out the interactions will be, this is the interaction between 1 and 2, right? 1 and 2 in column 3. So you will know this is interaction AB. Same thing. You can find out what is the interaction, say AC, A in column 1, C in column 4. So where is 1, 4? 1 and 4, which is column 5. So which means that column 5 will be 1 cross 4. Factor A in 1, factor C in 4, column 4. So the interaction of AC will happen in column 5. Do the same thing. You can find out interaction BC. So interaction AB in column 3, interaction AC in 5, BC in 6. Then you can have all the interaction and main effects. And this is called confounding structure. If you look at confounding structure for 3 level, and for each table, each orthogonal array table, you will find a interaction table like that. Okay. And this is for L9. Okay, let's look at the L9 maybe next week. Okay, but let's try. Okay, this is the interaction table for L27. I will explain three-level interaction table maybe next week. But here you can double check with the video tape and you will find out the interaction table for three-level will tell you that the interaction will exist at two columns. Say 1 and 2, the interaction will happen in column 3 and column 4 if your factors are three-level, right? And I will introduce that later, but you can see for each orthogonal array, you have one interaction table. But L12 and L10 are special. They will have no interaction tables. Again, I will talk about that later.